Okay, so now that we have our information all put in here, now I'm going to plot this thing. So I know that I need to plot my x-intercepts for my quadratic at negative 4.3 and at 1.3. My y-intercept is at negative 6. And my vertex is at negative 1.5, negative 8.25. So that's like right here. So this is what my quadratic looks like. It's going to be important that you plot these points correctly because they matter. Now, after we get done with our quadratic, the next piece is doing our linear. Now, our linear is our line, so I'm going to do that in light blue. So I've got negative 2, 0, which is here. I've got 0, 2, which is here. And then my points of intersection are at 2, 4, and at negative 4, negative 2. So here's my line. And I want to pay close attention. These colors don't look very different, but I want to pay close attention to the x coordinates of the points of intersection. That's going to be crucial. The x coordinates. Okay? Now we're doing this the same as last time, meaning that we're looking for above or below the line. So we're now going over to the symbol. And the symbol itself is that this is saying that where is the quadratic less than the linear. So we want the quadratic lower than or below the linear. That's what we're looking for. So less than means below. So we want below the line. And so I'm looking for all this. This is where the quadratic is below the line. Okay, so it's on a diagonal, but it's still below the line. All right, so I'm looking at x coordinates only. Now this makes a loop again, right? So because we make a loop, we're going to connect. And we're looking at the points between on the x-axis. Look, we're looking for these points right here where we connected from negative 4 to positive 2. So from negative 4 to positive 2, I connected. Now I'm looking at the x coordinates only. So I need to have a negative 4 and I need to have a positive 2. Now what I didn't talk about was whether it was open or closed. Now this has an equal sign, so it's going to be a closed circle because of the equals. And what makes people confused is the fact that it's on a diagonal. Don't let that confuse you. You're looking at the x coordinates of your points of intersection. And because we shaded in between them, like this is not two pieces, this is only one piece. This is one piece in between. That's what the loop does. That we're literally going to shade this piece in between. Again, we're only using the x coordinates only of our points of intersection. Now, once we have this, now I know that I only used one piece. This is what it looks like when I have one piece. It's in between. So when I go to write my solution, I'm writing negative 4 less than or equal to x less than or equal to 2. This is what one piece looks like. One piece symbolically starts at negative 4 and goes to 2 on the x-axis. This is one piece symbolically or on the number line where I'm starting at negative 4 on the x-axis, going to 2 on the x-axis. All of these values are shaded in from negative 4 on the x-axis all the way through to positive 2 on the x-axis. All these values are shaded in, okay? And that's how you do the problem.